Hello viewers, this is Pratiksha Bongale here with another video. In this video, we shall learn about the basics of NLP, which is the abbreviation for Natural Language Processing. Let's go ahead. Have you ever wondered how a machine like OK Google, Siri, Alexa, and Cortana answer questions posed by us? If you look at the representation at the top right corner, you can see that the search engine gives us exactly what we ask it for. If you ask it dresses, it gives you all kinds of dresses. You ask it for red dresses, it gives you only red dresses. Then if you type in red dresses under $100, it customizes the output, as you can see. How does it do that so easily and quickly? The key to it is NLP. So let's find out what NLP is. NLP is a part of the combined group of computer science, artificial intelligence, AI, and human language. NLP is basically the magic with which computers can understand what we say to it in our own language, be it English, Hindi, Marathi, Spanish, Turkish, Tamil, Telugu, Malayalam, any language, and gives us the result, if any, back in our own language. By doing so, it makes humans' lives easier to a whole new level, doesn't it? If you ask OK Google to remember something for you, it remembers that and tells you what you asked it to remember exactly when you ask it to. So that makes our lives easier, right? How does it make things easier? It does so by generating structured data from unstructured data. Let's find out what they are. In today's world, most of the data exists in an unstructured format, largely including texts that people exchange via text messages on social media platforms like Twitter, Telegram, WhatsApp, etc. So, in order to extract the useful information from these exchanges, it's highly essential for us to analyze that text entirely. Only when you analyze some text entirely, you get to know what the intent was, what it wanted to convey. So here's where text analytics comes into picture, which is usually coupled with NLP to obtain best results, where text analytics is nothing but generating useful insights from the unstructured data. Let's know more. NLP consists of NLU, that is natural language understanding, and NLG, natural language generation. NLU is understanding human language and converting it into an internal representation. And NLG is just the opposite, that is, converting internally created data and insights into human language for easier representation by humans. NLP has several applications. Naming a few are machine translation. Take an example of Google Translate, which translates a text given in some language to any other language quickly and accurately. Sentiment analysis, also called opinion mining or emotion AI, that helps us check if customers are satisfied with some product or service offered by an organization or not. This is basically used by businesses and industries to get to know what their customers actually like and dislike. Question answering. Machines answering questions in natural language is question answering. Examples are Google, OK Google, Siri, and Alexa. Chatbots. Chatbots are those that communicate with customers on behalf of the organization. Spell checking. Spell checking is an example of spell checkers in MS Word. You might have come across a few misspelled words underlined in red when you type in a document. That is spell checking. Automatic summarization is nothing but to convert a large amount of data into a short and accurate summary. Let's find out how all of these happen. So the steps in NLP are sentence segmentation. What sentence segmentation is? It is just breaking the entire text into different sentences. Divide and conquer, which makes the processing of the entire text easier. Word tokenization, that is breaking each sentence into different words called tokens. Lemmatization, Lemmatization is bringing every word to its base form. For example, walk, walks, and walking. All the three have the same base form, that is walk. Then comes parts of speech tagging. What is parts of speech tagging? POS. That is mapping each word to its part of speech. Let's take Bangalore is the capital of Karnataka, for example. So in the sentence, Bangalore is the capital for Karnataka, Bangalore is a proper noun, is a verb, the is the determiner, and so on. That is parts of speech tagging. Next step is identification of stop words, which are supposed to be removed. What are stop words? So in our previous example, Bangalore is the capital of Karnataka, is, the, and of are stop words. So we're left only with Bangalore, capital, and Karnataka. Next step in the whole NLP process is dependency parsing. Dependency parsing is determining how each word is dependent on another in the sentence. Then comes NER, named entity recognition. The goal of NER is to detect and label all the nouns with the real world concepts that they represent. For example, Bangalore and Karnataka are both geographic entities in our previous example. Lastly, co-reference resolution is mapping all pronouns to their actual meaning. Pronouns like he, she, and it are supposed to indicate to their respective nouns. Hence, this is used to process the entire text and bring out insights from it. What is word embedding? Word embedding is a method of putting similar words together for faster processing of the entire NLP process. For example, we have two kinds of documents, X and Y. We have had and gave together, Boston and Seattle together, talk and lecture together, science and research together. The common thing in all these four mappings, they're all related to one another. This is called word embedding. Word2Vec is an example for the same. Today's search engines also make use of NLP to enhance their working. Have you ever wondered how do you get your search results even without typing in the exact words in the search tab? There might be a few instances where you might have missed a few words or maybe misspelled them, but still you get the desired results. NLP does that look like no big deal. So Google has two main algorithms, and besides, Google's newer algorithm attempts to determine your search intent by checking on things like what type of device you are using, whether it's a mobile phone, a tablet, or a desktop. Secondly, are you typing or using your voice? Thirdly, number of consecutive searches. Fourth point, what else people are searching for? And finally, related topics. All of these make the algorithm work in an efficient manner. Let's try and implement a part of what we've seen so far. Let's take some Amazon reviews and find out what sentiments do customers have. So we import the necessary files and import the necessary text document, the labeled text document. So we have reviews and sentiments accordingly. So here we have the first one, good case, excellent value, which is a positive sentiment. So it has a sentiment value of 1. If it is a negative sentence, then it has a sentiment value of 0. What are the business outcomes? Since the data is labeled, we have the count for positive as 1 and negative as 0 comments separately. So in the entire Amazon reviews text document, we have 1,386 positive comments and 1,362 negative comments. Our next step is tokenization and text classification. After training and testing the model with numerous examples, we finally get our result. So if we type in, it was a good performance, which was never in the imported document, it still gives us that this sentence is positive, and bad product is a negative sentiment because we've already trained the model with a lot of training and testing. Try these yourself. So it's time to summarize now. Hope you have liked the content. If yes, then please do hit that subscribe button, like and share the video. Also, please do comment if you have any queries.